Hello, this is Shinichiro Horikawa, and today I would like to show you some little tips for VEX coding. Now what I'm going to show you is the automation way, how you can automate saving the functions for VEX as a global file, like a text file, like .h, and then use it with all over the Wrangles, using the same functions that you have saved in the text file all over the Wrangle node. I guess a lot of you guys are creating global functions outside the Houdini when you want to reuse it by using some IDEs, text editors. But for my usage, for my convenience, I wanted to do all the stuff just inside a Houdini without opening any text editor, external text editor. So what I'm going to show you today is to automate that process, saving the functions on a text file, then reopen it, reload it, include it as a VEX functions, just by using a Houdini. And in this case, I'm going to use Python node to do that. So let me first test by creating some functions that I want to reuse with the VEX code. Say I have a sphere node and set it to polygon, set the frequency to 100. Let's say I want to remove some of the points based on the noise functions with different kind of parameters using point wrangle, and I'm going to create some code to delete some of the points based on the noise functions. So first of all, I'm going to retrieve the point position, which is at p. So based on the position values, I'm going to first calculate the noise value using noise, and then I'm going to also multiply this with some scale value in order to control the smoothness of the noise. So I'm going to name this SC, as going to create a parameter for this SC, meaning as scale. Then I might also want to add a seed value so that I can shift the noise value. So let's also give a parameter for the seed. Let's make it CHF. Same for this one, CHF. Alright, and let's promote those two parameters by clicking this button. Okay, now I want to use this noise value to find out which points to remove. So if the noise val is less than some threshold value, so maybe I want another parameter which is named as th as a threshold. Okay, let's say if some noise value that I've created less than threshold, then I want to remove the point. Okay, so this is the function that I want to reuse over a different angle, a different wrangle. Now by changing those parameters, I can delete different values, different points. So let's create another wrangle having the same functions, having the same process, then change those parameters. We'll be able to create this kind of additively applying the same functions with different parameters will make something more interesting than just by using one functions. So there might be a case, so this is kind of one of the case you want to reuse the same functions all over in the different wrangles, right? And to do that, we first need to wrap the process that I wrote here as a function, then save it to a text file. So let's create a functions so that first of all I can save it as a text file. To do that, I am going to create the function, bring this over right here, then in this case create a void function, void, let's say remove points, remove noise, let's say noise remove. Then first thing I need is to access to this @p attribute and ptnum attribute. Now it's not possible to access to ptnum attribute inside of functions, but having the ptnum as a variable, you'll be able to access to this point position. So the first parameter for this function will be ptnum, right? And I have this sc, seed, and threshold, which I want to parameterize as well. So let's give that as well. So sc, I'll just say seed and threshold, since these are all float. Okay, now I have wrapped it with a void. Next thing I would like to do is to replace this position with a retrieved position using point function, accessing to a p attribute at ptnum, and I can just replace this ptnum with without an @ mark, and replace this @p with pos. Right now the function should work. It's time to call out this function by saying noise remove, and use ptnum for the first parameter, and this one for the second parameter, and the seed for the third parameter, and th for the last parameter. And let's see if this works. Okay, I think I'm having some errors here. Let's see what that is. Okay, VEX error, unable to load shader. It's not much information out there. Okay, I forgot to close this function with semicolon, so say semicolon, and now it should work. Right, so looks good. Now I have wrapped it as a function. Next thing I would like to do is to save this in a text file, right? And to do that, normally when you want to save the function as a text file and load it into a VEX code, you typically use a text editor, but I want to automate that without using text editor by using a Python node in this case. Alright, so let me do that. So for these two, I'm going to delete, and I'm going to keep this as a reference. And first thing I would like to do is to use the Python node, and let's name this save functions. Okay, and let's write up some code. First thing you need to have is where to save the file, I think. So in order to do that, I'm also going to import some modules that I'm going to use, which is OS. Right, and let's delete those, and let's give some parameters in order to define where to save a file, and what functions to save. Okay, so file. I'm going to first name the file parameter as file parm, is equal to node.parm. Now currently I don't have any parameters yet, but I'm going to create it right after I name this. So let's say I'm going to name the script file path where I want to save the file. Right now, right after I've done this, I am going to edit parameter interface and add those at the parameter for the string this time. So I'm going to give string, apply, and let me also add another string for the text editor in order to write the VEX code that you want to save as a function. Okay, so the first one, let's name this as VEX function, VEX, or maybe VEX snippet. Wait, I'll just say VEX functions, and VEX functions. Okay, and let's make it multi-string, and also let's set the language to VEX so that the code syntax will work by writing a VEX code, right? Now for the second parameter, for the second string, the one line is just fine, but for this one I'm going to name it as file path, where you want to save the scripting file. Actually, I have named it as script file path, so let's name it as it is. So script file path, script file path, right? Now set it as string and apply, accept. Now you can save the files at anywhere, but as a practice, it might be better to save it close to your file. So this is the folder that you're saving your file, this Houdini file. And inside this file, I'm going to create a folder like scripts. And inside here, I'm going to name the text file name named as functions.h. Right, so this will be the file which is going to be saved, which include all the functions written inside this VEX function text string. Right. Now inside this VEX functions text string, I'm going to copy what I have wrote here, which is this void function, paste it right here, like this, right? Now what I want to do is to save the text which is written inside this VEX functions named as functions.h using Python. So let's do that. Okay, first of all, I currently have the parameter name here, parameter object right here. So let's retrieve the value written inside this parameter channel by accessing the file param and evaluate. By doing it, you'll be able to get the value, I think. Open up the Python shell and let's check that out by print file name. And you get this exact directory or exact file path, which has been converted from this one. Right, looks good. Now it's time to create a folder, which currently I don't have right now, which is called as scripts, using OS module for Python. So first of all, I want to check if there is a path exist in this exact path that I have created right here, defined right here. So if not OS path exists and OS path their name, which means directory name, file name. So if the folder does not exist, then what I want to do, try creating the new folder with the same name. So OS make direction, OS make theirs, OS path their name, file name. What it does here is to retrieve the directory name from the file name. So right here. Right, and if I get any errors, catch it with an accept. And if any errors occurs, I'm gonna write it like this: error no exists, then raise. Okay, so this should create a folder, and let's check that out by going into the directory that I have saved the hip file. So here it is, and right after running the code, I have this, oh, not this one. So this is the hip file that I'm working on right now, and inside that same directory, I have this script folder being created, and inside nothing is there. So in terms of directly, it has been successfully created. Now what I want to do next is to save the text file inside a script directory. So let's do that next with using open file name with the right option and name it as F. And what I want to do is to just write the text, this string inside this file. So f.write. Now I also need to access to this string from the parameter. So let's do that somewhere around here, or maybe somewhere around here. Okay, so for this one, I'm going to name the parameter. First, I'm going to search for the parameter. So let's name this script parm equal to node parm vex functions. Okay, that's the name, I think. Yeah, and then use the evaluate to get the actual string. So script text is equal to script parm dot eval. Right. Now it's the time to. This is the string value, so you can now save this text inside this text file. Right, and I think the text has been successfully been saved inside its functions. And let's check, and here we go. You have this file, you have this VEX functions being saved in a functions.h. Now what you can do is to actually use it using with some wrangles. So I'm going to create a new point wrangle to actually load the file that I have saved. Remove noise. Was it noise remove? Okay, and in order to use the function that I have saved as a text file, you say include and go set the path for the file that I'm going to include, which was at hip scripts functions.h. Right. Now I think if it's successful, the function should have been included, imported. So let's try copying this line, then paste it right here. And if I don't see any errors, I think it has successfully loaded the function. And let's promote the parameter, and let's also set the range for the parameter. For the scale, I'm going to set it as from 0 to 10, seed 0 to 100, and then for the threshold 0 to 1 is fine. All right, now let's try to change those and see if the function is loaded correctly. Good, it has been loaded correctly. And let's also try using it by duplicating it and by changing those parameters, and works just great. Now there is one problem using this method, is that if whenever I change this VEX functions, say I want to cancel removing the points, now the VEX code doesn't seem to update unless you type like extra return key or something. Until then, you not get any updated code. So that's a bit of time consuming. Sometimes you don't know which VEX code to update after you have updated this global functions right here. So I'm going to show you the last tips, how you can get a updated, how you can forcefully update those wrangle component as soon as I change the function, change the function inside the Python code. Right, so currently now all the functions, all the wrangles are using this loaded functions, but right after I enable this one again, now I have to do the same step again, like pressing return for each code. Now that's not a good process, that's not a good practice. So I'm going to forcefully update all those wrangles node by using Python. Okay, to do that, go back to the code editor. And first thing I would like to do is to retrieve all the Wrangle node out of the group. So what I'm going to do is retrieve all the wrangles in the same node, as well as the node inside the children inside each of the node by using, first of all, use nodes with who dot node, and this will be the current node network, which is inside a geo1, which is equal to geo1, and then inside this geo1 I want to retrieve all the node by using .all nodes. Okay, now, and I'm going to access each of the node using for loop and check the name of this node. Now first of all, let me try opening the Python shell again and print out the name, what kind of name that I got. Accessing to the name property. Now here are the list of all the nodes which inside this geo1 node, geometry network. And the one that I want to access is not actually those wrangle, but actually the one that's inside this wrangle. And there's a VOP network inside each of the wrangle. Let me check that by creating a duplicated wrangle here. And if I say allow editing of contents, there's a BOP, attribute BOP. And actually, if you open up the edit parameter interface of this one, go to the from nodes, and inside is attribute BOP. And if you go to the VEX setup, there is a button called force compile right here. And you can check that by going into the VEX setup tab here, and there is a force compile button here. So by pressing it, you'll be able to update the VEX coding by reloading the external functions as well. So what we want to do is to activate this button inside the Python using the Python for each wrangles. To do that, we need to access to this attribute BOP. And for each wrangle, the name of the attribute BOP is always the same, which is named as attrib BOP1. And you can see several attribute BOP1 being retrieved using this all nodes like this one. So now that we know what attribute, what node to access, we can first filter the node by checking the name. If the end name is equal to attrib BOP1, then we want to get the parameter for the force compile button. Now I might want to check again what exactly the name for the compile button. Going to the from nodes for the attribute BOP, look at the VEX setup, and the name of the VOP compile force compile button, or this one, is named as VOP underscore force compile. So this is the name of the parameter, name of the button which you want to retrieve. So let's retrieve that by saying button is equal to a n dot a parm, and the name of the channel is force, name of the button is force compile. Right, now you can activate, you can virtually press the button using Python by accessing to the function called press button. Okay, and let's close this. Go back to the geometry node. Let's delete this, and let's see what happens if I press apply and see if the code it's going to be updated. Press apply. Okay, I do have some errors. Okay, some name convention name typos. Should be parm. Now apply. Okay, the code, it has successfully been reloaded. Now let's check that again by going back to the Python node and look at the VEX function strings. And if I do the commenting out, now all these code has been updated instantly. And if I uncomment this remove points, then the function has been loaded as soon as I type exit this code editor. So it seemed to work well. Okay, so that's it. That's how you can save your functions using Python so that all those processes can be done just inside Houdini, which some of you might, it's not necessary for you guys, but for my case, it was pretty useful without it using any kind of IDEs. So I wanted to share this with you guys. So that's it. Thank you for watching, and if you like it, please subscribe for next video. All right, thank you and bye.